Hello, everyone. Welcome to Tangyo's Cell and Module Production Equipment and Processing Materials Conference. As Michael said, I'm Shravan Chanduri. I'm Head of Technology at Tangyo's, basically responsible for technology-related stuff we publish at Tangyo's. So without any further delay, I would like to invite Markus Fischer for giving the keynote speech on evolution of cell production technologies. Markus Fischer is a steering committee chair for ITRPV. Probably you would also see a lot of references for ITRPV in the upcoming presentations. Markus, the floor is yours.
So can you see my screen? And
yes.
Can you hear me?
Perfect.
So Shravan, thank you very much for the introduction. So I will give you an overview about the 15th edition's ITRPV findings in the fields of materials, processes, and products. And this is the agenda I will follow. So first, a brief ITRPV status, then review the results. So results were collected last year from more than 50 contributors worldwide, and then I will close with an outlook and summary. So here, this is organization of the ITRPV. This year, for the 15th edition, we had about 50 contributors from Asia, Europe, and US. More than 70 parameters are reported, and we for this year we reduced a little bit the number of figures. Anyhow, the contributor share was well balanced, so between materials and equipment suppliers, manufacturers, R&D institutes, and consultings. So all the diagrams that I will show the median values, and therefore you can interpret the results accordingly. So as Michael mentioned at the beginning, so we had last year enormous shipments and installations. So overall, we calculated the shipments of last year to 502 gigawatt peak. So, and what is very crazy is the extreme low price, so the $12 at the year end of 2023. So installation overall was assumed to be around 440 gigawatts, and this leads here to the overall figures of 1.7 terawatt shipments so far. And overall installations 1.5 terawatt. So that means we are approaching here the 2 terawatt level. And what we see here, production capacity, this was also reported, is about 1 terawatt. So for wafer, cell, and module. So 97% is silicon based, but this caused here a quite serious overproduction situation, oversupply situation. And nevertheless, here, if we follow the overall learning, so we see learning rate from 1976, where we had the first figures here, to end of 2023 is about 25% learning. And if we look here at this accelerated learning from 2006, we are close to 40%. So learning continues. Nevertheless, we are in a tremendous price reduction and low price situation. And for overseas, on top, beginning of this year, there was also an increase in shipment coming. So anyhow, we are facing a serious situation, but development will continue. And I will give now here the results that we found. By the way, the presentation of the 15 or the publication of the 15th edition will be published target is to publish it end of May. So here we see the share of crystalline silicon material in the market. So we see here for this year, so there is a share of N-type of about 30%. This is close to the SPGI analysis results. And mono PERC last year was still the main working horse, yeah. So mono P-type. So, but it is expected that for this year and for the next 10 years, the N-type share will increase significantly. And so the PERC technology share is expected to go to around 10% within the next 10 years. So what is going on in parallel with this material? So there we see the material appearance of larger wafers. So in 2023, so the expected share of G12 format was about 30%, and all the other smaller wafers. So the biggest share is the 182 times 182, the M10 wafers, with some new formats, rectangular formats, M10R. So this 182 times 109X, or then the G12R with 182 times 210. So the share was close to 65%. And the M6 format, still present in the market, is expected to disappear within next year, within this year. And so the clear winner of the formats is not fixed, but anyhow here the large formats will dominate the market, and this is also a benefit for the economy of scale in the production. So how is the economic use of silicon developing over the next years? So this is what we found. Here, as the example on the left side, we have the polysilicon consumption per wafer, and we calculated with the figures of the ITRPV the corresponding value of grams per watt peak for the cells. And there we found that we are currently here in a level for the M10 wafers, so with around 1.8 grams per watt, and with 210 it is a little bit higher, but anyhow, so we see that this development, so there will be a significant reduction in consumption over the next years. So that this will show here also a further economic use of the silicon material. So, and what we see here, how is this realized? So by improving the crystallization method and the wafering technologies, thinner kerf loss will be realized, but a significant contribution is the wafer thickness. And we showed here the different wafer thicknesses for the different technologies, and we see that here for the P-type material, so currently we have the 150 microns as standard, but expectation is that they will go to 130 micron, and then it will stop with the PERC technology. But here for the N-type materials, we see that heterojunction is using the thinnest wafers. So currently in the market for heterojunction in the M10 format, it is 120 in 2024. So but for the TOPCon, we are with 130 in the market, and the expectation is that this thickness will reduce. Anyhow, we have to consider for the thin wafers, especially with the large format, the bending. So for heterojunction, they use cutted wafers, so half wafers or third wafers from the beginning. for the other technologies, this has seriously to be considered for the future. Anyhow, the reduction will continue. So now the important thing is what I mentioned before here, the share of the technologies. So clear, the dominating PERC in 2023 will reduce the share, and it is expected to lose share for N-type, and then here biggest share is with TOPCon currently, so up to 50% in 2024. And then heterojunction is with a less share, and then we have also IBC, and the expectation is that tandem will appear around 2026 with a very, very small share, but anyhow, it is expected to overcome the situation with the limitation of efficiency. So here, all these technologies that will be in the market or are in the market are ready to be used bifacial. So how is the improvement continued? So we have here in the ITRPV reporting, have been reporting the J0 values for the different materials. So in there we see for N-type, we have clearly lower J0 values, and this is a big argument for the improvement for the use of N-type. So how is this improvement realized for the J0, especially here for the front sides? So with the doping technologies, so in PERC we have only selective emitter in the market, and for boron emitters, so selective emitters will also be introduced, and the sheet resistances will be increased from the 115, 145 to 185 ohms per square region. So, and the technology that is used in the market for boron is mainly BCL3 in the future. So then for rear and front side perseveration for PERC and TOPCon, so ALD is dominating in the market. So we will also see some presentations in this conference, and for the rear side passivation. So the race is open between LPCVD and PECVD. So that is not quite clear who will be the winner. Anyhow, the thickness of the rear polysilicon is reduced. So in here, regarding the throughputs of the machines, so this is very important to be efficient in mass production. It shows that the throughput is expected to increase, and batch processing, especially for the wet tools, is a throughput leader, followed by ALD. And then we see here for the deposition, so there the throughput is quite lower, but anyhow, there is also a lot of improvement in the market possible. So an important cost element of the current cells and modules is silver. So, and the graph here shows what is the consumption per cell and what is the consumption here per watt. So the value is milligrams per watt and tons per gigawatt. So this is quite easy. So, and we see here, so the average consumption for the TOPCon is about 9.50 milligram, and for the PERC it is about 9.6, so it is lower. So this is quite important. But anyhow, the expectation is that the reduction here for TOPCon is continuing, and we see here that the tier 1 manufacturers are well on track regarding the silver reduction. So that means that despite the high costs, so currently it's about 1 cent per watt cell in the market, but the overall, the world consumption of silver is still in the range of 18.2% of annual silver consumption, and this will can be handled also for larger capacity. So how is the silver consumption realized? So first of all, by using more bus bars or going to bus bar less, then also to reduce the finger widths. And these are all measures that can be driven forward. So throughput for metallization tools is quite important. It will be increased, and there are new technologies that will be used for this improvement of throughput and also performance for silver consumption. So an example is the LICO technology of Q cells that enables here with an extension by a laser. So a very efficient use of the silver and an increase of efficiency, and Q cells and CE are patent holders here and are committed to defend the IP. But anyhow, licenses will be available for interested companies. And here you see the results that Q cells reached with this technology. So we have here with introducing the LICO, we could realize and demonstrate production efficiencies of 25.4%, and best sellers are 25.6%. So efficiency trends quite clear. So the dominating TOPCon and are currently in the range of 23, and for TOPCon 25%. Heterojunction is also in this ballpark, and for 2026 we expect to overcome the limit of the single junction, that tandem will be introduced in the industry, and this efficiencies will then go beyond 30%. So regarding modules, so the mainstream modules are using half cells, and the interconnect will be used with copper wires. So cell thickness limitation is not there for module, and for the application, so power plants will dominate, and also some new applications for agro PV, built-in PV, floating will appearing as big niches in the big market. So system cost. So what we see is that the system trends, system degradation. So the modules degradation from 2% will be going to 1% within the warranties degradation. And the annual degradation will also reduce, and system degradation is expected to stay constant at 0.5. And for inverters modules, you see here the expected useful lifetimes that will also increase. So regarding LCOE, we have here the clear trend that all numbers are going down, and the LCOE are in the different insolation regions at low levels. So around the lowest levels are around 5 cents, and here in the high insolation regions down to 3 cents per kilowatt hour. So the very impressive improvements. This leads me here now to the outlook. So if we look here on the different learning rates for efficiency learning and for per piece learning, so it continued. So despite here some stop here in the last years due to the switch to the format, so this continues, and the combination of efficiency increase and continuous cost reduction per piece will lead us also through this difficult situations currently. And we have a bright future. This is quite clear. So in the ITRPV only discuss now this scenario, the 2050 scenario by Breyer et al. Assumes here contribution of PV within 2050 to about installed power of 63 terawatt peaks. This will result in 4.5 terawatt annual market. And if we look here, we track the current shipment. So with a 502 gigawatt, we are well on track in this impressive curve. And also, EAR scenario from our point of view is quite too conservative. And we from ITRPV will guide you through the next level of PV manufacturing in the several 100 gigawatt, 500 gigawatt plus markets, and also in the terawatt market. So efficient use of all materials will be the key, and ITRPV will show the way. Thank you very much for your attention, and thank you very much for all contributors to contribute. You are the base of these figures, and so you are invited to contribute. And to participate in the ITRPV, and yeah, new edition will be available also as PDF. So latest here end of May. Thank you very much.
Thanks a lot, Markus. I think that was really very sunny outlook. Thanks a lot for this very brief overview of all the technologies. So I have one question. When you have been working on ITRPV from several years, so especially for this year, what really surprised you compared to last year? You know, something that might have said, oh, wow, this is really what we have not expected. Is there anything that kind of changed?
Yeah, first of all, the impressive price drop. So when I prepare here the installations, installation and shipments. So this was the first thing, and then this tremendous drop in price. So this was what I was really surprised and impressed. So and then the big progress here regarding the introduction of TOPCon. So this is also impressive that now for the next months to come and years, so TOPCon will dominate. And then also this yeah, impressive continuing of reducing the thickness of wafers. So these are the three things that I was very impressed while preparing.
Okay. And do you have anything to say on the overcapacities? Right now, it's all along the value chain. So just Michael also said, right? So at some point there are overcapacities, yeah, but then people are also expanding a few companies in different regions, of course. But
yeah,
so,
yeah. So this is really a threat for the industry. But anyhow, we have to keep pace with the new technologies. And we have also to look to make the existing installations more efficient. Yeah? So there will be also a replacement market. Yeah. So for the installation, so there is a gap between shipments and here the installations. So around 60 gigawatt. So there is room for repowering. Yeah. So this has to be considered. So, and this is also important. So for this repowering, we need recycling. Yeah, so recycling industry will also be very, very important for the next years. And expanding in new capacities is one thing, but also using existing. So, and there QCell shows perhaps here a mean here with this LICO technology to efficiently use the existing technologies. So by boosting here the efficiency by the slight adjustment of the backend. Yeah, so there are possibilities to keep pace with increasing capacity, but yeah, so I think expansion will slow down, but anyhow it will continue. Yeah, it has to continue to meet here the 2050 targets.
Thanks a lot, Markus. Thanks a lot for this presentation. I think there are also a few questions in the chat window. It would be great if you can answer them.
I will have a look and then I will answer. Yeah.
Thank you.
Yeah. Okay.